Hello, guys, and thanks for being here for this last session of track number 1 of DDD 2021. Let's just take a few seconds to remind the code of conduct for this conference and to thank our sponsors who have made possible for us to be here today, albeit not in person. Hopefully next year will be better. Thanks from me in particular. My name is Marco. I'm a development technology MVP. I've been an MVP for the last 12 years. I've been a speaker. This is, I think, my third time as a speaker at DDD, and I'm particularly excited about this talk, which is about testing scenarios, advanced testing scenarios for ASP NET Core. I've been thinking about this talk for quite a while, and I'm really happy that I found enough time to prepare it for this conference. So I hope you will enjoy it. Let's start by talking about what's not going to be in this talk. All right. So we're not going to talk about unit tests or test-driven development or mocking. I'm pretty sure every one of you know these concepts inside out, right? If you don't, or if you feel that you have some gaps, there's plenty of material on the internet, or pluralsight courses, or webcasts, or past talks at conferences. However, I think that there's more beyond unit tests, and this is going to be the topic of this talk. Because I don't know you, but I've always had the feeling that unit tests don't tell you the whole story, right? Sometimes you have a feature with 200 unit tests around it, and yet it fails in production, right? You have bugs. So sometimes they just fall short on representing the reality. And this might be because for a number of reasons. One main reason is that with unit tests, we tend to mock all of our dependencies. So as long as our mocks behave exactly the way the actual classes will, my test will be realistic. But there could be chances where this is not the case. Some of the times, we get to build tests which are so complicated that perhaps it's not even easy to understand what the test is about, right? What is the scenario that we're testing? And if that's not easy, it's also difficult to make sure that the scenario is represented correctly, so that we've implemented the test in a proper way. We're testing the right thing. Other times, like I like to say, the devil is in the integration. So there's nothing wrong with a class or another class, right? It's just the way that behave together, which might be hiding some issues, right? Or some complexities that we need to test. But I don't know you, but most of the times I've tried to implement integration tests without, just by deploying my application and making it run. Everything has become very, very painful all of a sudden. So if you have had those experiences, I hope you will enjoy this talk, right? I'm going to present a few techniques that I've been adopting over the years in real world projects I've been running for my clients. And hopefully there will be things you already know, or perhaps that you didn't know, and you might be willing to use for, in your real projects, starting from perhaps next Monday. You never know. So let's get started and see where we get to. Now, let me go one sec to Visual Studio, because I want to present you the playground that we're going to use throughout the talk. And it's this fake bank API. It's a web API project that tends to represent the basic functionalities of a bank account or a banking institution. For example, I have my accounts controller, which is accepting a few dependencies like an account service, authorization service, etc. And what it does is exposing the basic functionalities like get balance, get statement, make a deposit, make a withdrawal, right? And in order to, so this is a kind of a thing controller, right? So in order to implement the real functionality, I've been using a specific application service called account service. And if we go and have a look at this account service, we can see that, I don't know, internally, it also has a few dependencies, right? It uses entity framework in my case, but it's not a requirement for what we're going to see in a moment. But it's just a way that I'm using to interact with the database. And basically, it exposes pretty much the same things that we talked about before, right? So deposit logic, withdraw logic, etc. All right. So let's think about the first step that we always have to go through when implementing a functionality, a new functionality in the application, like I don't know, those of which I've created here through account service. And this is basically doing functional testing. Now, one of the techniques I think are the most powerful ones to implement functional testing is via behavior-driven development, or BDD. What is behavior-driven development? For those of you who have never used it, well, it's a kind of a paradigm shift from unit tests, because in unit tests, you create a class and you create a test around that class, right? And therefore, the test per se is focused on the implementation of, well, or I would say on the implementation details of the solution, because we're talking about classes, right? Or we're testing methods, behaviors of those classes. With functional testing, we instead create a test that describes the functionality from the point of view of the stakeholders, like you can see in this quote from Dan North, which is more than 10 years, goes back for more than 10 years. And there's a very well-established tool in Visual Studio to implement BDD techniques, which is a SpecFlow. You don't have to use it, but it's probably one of the standards for today in Visual Studio. It's free in its base version. There's a payware version, but all the things that we're going to see today are made on the base version, so you can just use it. And basically, the BDD allows us to write a scenario, a test in this way, like in plain English, right? Saying, I don't know, something like scenario airplane takeoff. And the test is given that the airplane is on the runway and the airplane is running at 150 knots. When I pull the yoke towards me, the airplane takes off. All right. OK, so let's see how we can apply some BDD concepts to our account service, right? Now, in my Visual Studio, I've already installed SpecFlow, right? It's here among the add-ins that I have, which is, yeah, obviously under the tooltip, right? And once you have it, the only thing that you have to do is, I don't know, go into your test project. Well, adding a few dependencies, but there is a template for a test project that already contains all these dependencies. In my case, there's a SpecFlow for XUnit, the XUnit provider for SpecFlow, and this one, which was meaning is going to be evident in a moment. And after that, you can just add a new file to your project. And you can select the SpecFlow here on the menu, and more specifically, you can select the SpecFlow feature file. So, for example, in our case, we're gonna I don't know, add an account operations.feature file. All right, and as soon as I have it, I can start writing my my features. So you don't want to see me typing, so I have a few snippets, but yeah. So this is my main test, right? Account operations test account functionalities for Bank API. And we can write our first scenario, which is a check account balance. Given an account ACC 0123 exists with a balance of 1,000, when I check the account balance, then the balance should be 1000. Okay, so this is the first test, behavioral test that we're going to implement. Now, as you can see, the text is written in purple, right? And this is because there is no C# code behind these English statements. So that is going to be our next step. And the easiest way to create mockups for these C# code blocks is clicking this generate step definitions item in the context menu, right? So I can just right click, generate step definitions. It will say, yeah, there are these 3 steps that deserve a C# code, some C# code. So just copy the methods on the clipboard. And at this point, I can add a new class to my project, which conventionally is called account operation steps. Right, now that I have my account operation steps, I can paste, and as you can see, SpecFlow was capable of recognizing, well, creating the structure of my methods, but also recognizing that in some cases we have parameters or things like that, right? So for example, here we have the first parameter, which is the account number, and the second parameter, which is the initial balance, for example, right? I needed to add a few usings here and there, and I also needed to add an attribute here on this class called binding. Apart from that, I think I'm good. Now, the way the test will run is that SpecFlow will call these methods in sequence, right? So we need some way to store the state of the test that each method will alter, so that at the end we can verify that state. And we could do that just by adding fields onto this class, or again, it's a convention, but typically what you do is adding a separate class for that, which we call account operations context. Right. So we have our class here, and this is where the state of the test is going to be stored. All right. So let's start by modifying, creating a constructor here on this class, where we can inject our test context class, all right, account operation context, and then we can prepare our account service that we want to test. Now, if you remember, the account service has a couple of dependencies, an IDate provider and a bank DB context. Now, let's deal with the IDate provider first. And I can just create a mock for it like this one, okay? I'm using mock for this, and yeah, we have it. Then what about the DB context? Now, here is where things start to get a bit more complex. Now, typically, what we could do is, well, either we could hide this DB context behind an interface to make the class more testable. Yeah, that's fine. It's something that we might want to do. Or since we're using, probably if we were using something else like Dapper or an iRepository, whatever, that would be definitely the case. But since we're using DB context, we have, so in this case, we have Entity Framework. We also have another tool on our belt, right? And again, this is specific to Entity Framework, but it's not going to be mandatory for the kind of approach I want to show you. But in my case, what we can do is registering the DB context to use an in-memory database, which I've called account operation, right? So this is a fully fledged database, but it runs in memory, so we have no dependencies around. And once we've configured the context option builder in this way, we can just create a new instance of the DB context. In this way, we save it onto our context class. And there's one important bit that we have to remember each and every time. So even though the database is in memory, it's still a proper database. So its life cycle spans with is the same of the test runner. So this means that every time we run the test, so every time this, which will cause this constructor to be run, we need to make sure the content of the database is deleted, because otherwise it could be that the second test will find some spurious content on the database remaining from the test that is run before, and that might invalidate the results of that test, right? So we need to make sure this is the first and foremost rule when we need to work with databases. So making sure that everything is deleted each and every time. All right. Now that we have the DB context, we can just create now finally our account service, right? Just by injecting all these dependencies. So we have our service under test now created, and now we can go and start implementing these methods. Let me just modify these because they will be asynchronous. Obviously, SpecFlow supports asynchronous execution of the methods, and let's start by adding some code here, right? So given an account exists with a balance of, what does it mean? Well, it means that, well, first of all, we need to store this account number, obviously, because it might be useful later, right? And then we can just create an instance of an account and adding it to the DB context and then saving it into our in-memory database. Okay, so at this point, the account will effectively exist in the database. Then we need to check the balance. And in order to check the balance, we obviously call our service getBalanceAsync, passing the account number that we stored before, and we save it in another field, which is current balance. Okay, and then the last step is verifying that the balance should be whatever we passed on the method. So let me call this expected balance. And at this point, we can just go here and type a normal assertion like this one. Okay, assert that the expected balance is the same as the current balance. Okay, now if I compile the application, SpecFlow will generate some code for me in a horrible class, which will hopefully never have to deal with, like this one. But the good point is that if I then go to my test explorer, let's just run it. It takes some time to refresh, but basically what will happen is that as soon as it refreshes, yeah, as you can see, there's now one test, which is account operation features, check account balance, and yeah, my test is effectively passing. Okay, now we've built our first test. If we go back to our feature file, as you can see now, the text is written in white, just to highlight that there's a code behind these statements. But I hear you being a bit skeptical because we have effectively written a lot of code for such a simple test. So does it get so verbose? Well, the beauty of SpecFlow and this approach in general is that we can reuse a lot of code. So let's say that, for example, we want to create a second scenario, which is, for example, deposit, right? If we want to write a scenario for a deposit, we can reuse pretty much all the statements that we already written. So we can just type something like given an account exists, and then say that, I've made a deposit, of 100, and then I can reuse this code entirely, right? Like this. I just need to change some parameters, and all I need to do is implementing this line of code to have a brand new test, right? I can go here, say go to step definition. This step doesn't exist. Do you want to create a mockup in your clipboard? Yes. Let's go to the steps. Go here. Wrong. I just make it asynchronous as before, and I need to add this snippet of code that I have here. And as I build the code, I have a brand new test for the deposit as well, which, as you can see, is running now. And now I have two tests made in my test suite. All right, and this thing can go on for as much as we want, right? So, for example, if I switch to this different branch and I go and have a look at this account operation feature, I have written lots of other tests, like for withdrawal, for transactions, and you can use this table format to, for example, represent a lot of different transactions. I can use the same table format, for example, for the assertion. There are a few helpers which are extremely helpful in SpecFlow to deal with this kind of a tabular object in a very easy way. Go and have a look at the code. But the concept that I want to tell you, which is the most important one. Oh, these are, by the way, are purple just because SpecFlow doesn't play well with branch changes, but the tests are effectively there, and if I run them, hopefully they will be all green. So what I was going to say, the most important bit of BDD, what I think it's the absolute plus of it, is that your stakeholders will understand it, right? So you can go through all these tests with your stakeholder, and or perhaps you can pair with him, or perhaps they will provide those tests to you, and you will only have the overhead of creating the C# code behind them. So the beauty of BDD is that there's very little room for misrepresenting a functionality or perhaps implementing it not in the right way because we haven't understood the requirements correctly. All right, and I think that this is incredibly powerful, at least from my experience. So we have all our tests, they are all green. So let's try to launch the application and see if it works, right? So Control F5, the application will launch, and let me go to here. I have, since the account service, the account controller is behind authentication, I have a code snippet, the PowerShell code snippet to make the call. So let's try to make a call and retrieve a balance and see if it works. Right. Is this code? All right, I run it, and all of a sudden I get a 500. Right. So unfortunately, this is one of the cases in which, even though my tests are all green, actually there's something which is not right with them. And if I go and have a look at the log here, I can quickly understand that there's something wrong with an expression that cannot, for example, in my case, could not be translated from link to entities into a proper SQL, right? And I bet that this has happened to you hundreds of times, right? You have written your code, and there was I don't know, a complex join or a complex clause that simply EF could not translate. But the same thing might happen if you, for example, were not using entity framework at all. Perhaps your logic was in a stored procedure in the database. Now, if we're using an in-memory database for EF, or perhaps we are mocking our database entirely, these things will never emerge from a test, right? So the next step will be to try to understand how we can include the database in our tests, because sometimes it's the only way to properly catch those bugs, right? And how do we do that? Well, what I've done here is if we go to the properties of my bank API, I have created my bank API test. Sorry, I have created a configuration DB test, which includes this compilation symbol, right? And which is a DB test. And what this thing does is that I can rewrite my constructor in this way. So basically, if I'm in debug mode, I'm using an in-memory database like you were seeing before. But the moment I switch here to DB test, right, I can actually run a test against a proper SQL server. Now, I'm pointing to my local DB, which is OK 90% or 99% of the times. And it all works provided that you take a number of steps, some steps, right? So first of all, I'm obviously rolling out the schema on that database. I'm using migrations here, but again, if you're not on EF, for example, using Dapper, you just, I don't know, run a script against your database. It doesn't have to be on the test. It could be done one-off when against your test database, and that's it. But the single most important thing is again that you need to delete all the data that any test could potentially create, so that the database is reset each and every time a test runs, right? Now, if I run these tests again, now that I'm in DB test mode, let's see what happens. Well, effectively, I can see that there are some things which are not working correctly, right? So, for example, check account balance is failing, like it is failing in our actual application. So what I can do in SpecFlow is go in here and put a breakpoint on my English text is written in plain English, and go here and say, I want to debug this test. This will launch the test in the Visual Studio Debugger. And I can do all the things I could do if this was a normal C# piece of code. So I can just, for example, step out this. I can step in here. I can check the account balance, and this is basically the problem, right? I tricked you. So I'm obviously using a get hash code in my query, which is not translatable in SQL, and this is what is generating my error, right? If I go here, uncomment this line and comment this out, and I now run the tests, everything should be working correctly. And in the meantime that the tests are running, yeah, all is green. I go here, I run the same code as before, and now I'm getting my response, right? So this is one easy way you can use it to involve the database. It's not difficult. The tests, as you can see, are running relatively fast. 8 milliseconds, 56 milliseconds. There's just an override in my case for the migrations run on the first test. The only caveat is that you need to make sure that each test runs from an empty database, right? Cool. What about Azure DevOps? Can we do this, for example, in our build pipeline? Yeah, we can definitely do that. Let me just move to the pipelines here. And in this pipeline, for example, what I'm doing is, as you can see, well, it's just a normal build pipeline for .NET Core. So I'm just doing a restore, build solution, etc. The important thing I'm doing here is this block of code, right? So I'm starting the local DB instance on this build agent, right, with SQL local DB start ms SQL local DB. This is possible if you are using a Windows build agent, obviously. Otherwise, you need to come up with some other solution, like using a test database somewhere. And the other thing is I'm running the tests, passing the configuration DB test. Apart from that, it just works. And so this means that you can safely run your tests in with a build agent, as well. The other thing you need to remember is that obviously these tests don't play well if they're executed concurrently, because some tests might store data which is then read by the other test, invalidating the logic in it. So you also want to disable the parallel execution with, in the case of XUnit, for example, with an attribute like this one. Okay, apart from that, we good. Right, so let's move on, and let me just jump to this other branch, because there's another interesting thing, an interesting experiment I want to do with you. So in this branch, the code is pretty much the same as before, right? I've made it just one little change. If we go and have a look at this account service, the account controller, what I've done is implementing a logic here to make sure that only the owner of an account can actually see the balance of that account, which is what you would expect. So as you can see here, the controller is protected in my case by Azure Active Directory, right? So what I'm doing is that there will need to be a JOT token in the request, right? I'm retrieving the user from that JOT token, and well, from the HTTP context, obviously, actually. And I'm also retrieving the balance from the account number, by the account number, right? And then I'm running this call against the authorization service to check if this policy is valid. Same owner policy is a policy I have created, which internally checks that the owner of this account is the same as this user here, right? And it's implemented by this account authorization handler, right? So there's an authorization handler, same owner requirement where, yeah, as you can see here, I'm implementing this logic. So I'm checking if the user of the current request is the same owner as the account balance. If it is, it succeeds. And if this request succeeds, I'm returning effectively the balance. Otherwise, I'm returning a forbidden. All right. Hopefully the logic is clear. How do we test this? Yeah, here things are becoming a little bit less trivial than before, right? So one option could be, yeah, let's just do unit tests, all right? And I've created a couple of unit tests for this. So I've created, for example, a unit test for my controller. So my accounts control unit, let me run them in the meantime, and then in the meantime I will explain you the code. So here, for example, I've created a test that checks that if the owner is different, I get a 403. How do I do it? I have to mock a few things. I have to mock the account service. I have to mock my HTTP context accessor to retrieve the HTTP context. I have to mock the authorization service. And here I'm saying, for example, in this mock that this authorization service, when called, will return failed. All right. And then I'm making a call to the method get balance async of my controller, and I'm expecting a forbid result. And I'm doing a very similar thing here for the happy path, right, in which the owner is the same. So I'm saying that the authorization service returns success, and here I expect to see the proper balance. Okay, I've also added some unit tests for my authorization handler, right? So this code here, account authorization handler, in which I'm also mocking a few things, but I'm verifying basically that if I make a call, passing the requirements, blah blah blah, and for example, the name in the claims principle is the same as the owner, this should return succeeded. Otherwise, it shouldn't return succeeded. Okay, in this other test, in which the owner is a different name than the actual one in the claims principle. Okay, and if you can see, these tests are all green, right? I think they're reasonably good unit tests, all is green, so I'm confident that my application will work correctly. Now, how do we prove that? Well, let's go and have a quick look at the database here. I have a couple of accounts which I've created. One is entitled to someone else, and one is my account, right? So let's try to run, for example, the other account first. And effectively, I'm getting a forbidden, like I was expecting. That's good. Let's run the other account, something which is less good, right? So I'm getting a 403 forbidden, even though I'm the owner of that account. I can guarantee you that the access to the database works. The unit tests of my components are saying that everything is good, and yet my application is failing. All right. So how can we try to deal with this? Well, the point is that this is one typical thing where, I like to say, the devil is in the integration. So we need to understand not only that these components work well by themselves, but that they can integrate properly between them. And the best way to check this is by running the entire ASP.NET Core stack and verify that everything works correctly. All right, so we need some integration tests that will involve the entire ASP.NET Core stack. Cool. So let's try to do that. And but since I might want to introduce a few concepts, let's start with an easy kind of test, right? So let's just test this controller here, right? I have a values controller, and let's start with an easy thing. I want to make sure that if I call this method, this action actually, I get a 200 and a response, all right? So let's try to write a test for this. So I'm going to create a new folder here. I'm going to call it web, and I'm going to create a values controller test. Cool. Now, this values controller test. So what is the test that we want to write? So something like this, right? Values controller, when called, returns 200. All right. And in order to do that, I can use an object called web application factory. All right. I could just run my program, my program.cs, spin up Kestrel, but that would consume an HTTP port in my database. There's a more clever way to just run the ASP .NET Core stack without consuming an entire port, and this is through the web application factory object. I have a code snippet here for this. No, I don't. Okay, so I do just a var factory equals to new, web application factory. And here I needed to provide an entry point. What is an entry point? An entry point is a startup class, basically, of a web application. Now, I could use this startup class here of my bank API, but bank API has a problem of registering a number of dependencies. And this would add a lot of complexity to my integration test. I do want to write an integration test, but an integration test which is as minimal as possible, right? And I certainly don't want to deal with things such as, for example, the database or Azure Active Directory during my test, right? So instead of doing that, what I've done is creating a dummy web application, right? Which is pretty much the same template as when you create an empty ASP.NET Core application, all right? Whose startup class is way simpler, right? It just configures the some endpoints and that's it, all right? So let's do that. So I'm going to use dummy web app.startup, and now, since my controller is defined in a separate web application, I need to configure my web host, my web host, to also add the controllers coming from my bank API application, right? So that's why I'm using this services.addControllers.add application part passing the assembly of my bank API. I just needed to add a using for this, which is a Microsoft.extensions.dependency injection. Okay, so at this point, what this creates is that it spins up my application in memory, and I can create a client to call this application just by calling the create client method. Now, this is a fully fledged HTTP client class. All right, it's just configured with its pipeline of middleware, so its message handlers, to, instead of making a real HTTP call, to call the runtime, which is provided by this web application factory. But apart from that, it works exactly like a normal HTTP client. So I can just do something like var response equals to await client dot get async, and if I'm not wrong, this should be the URL of my call, and then the test is going to be something like response dot ensure success status code, for example, something like that. Let's try to run this test and see if it works. Yeah, it's running, it's green, and to demonstrate that I'm not cheating, I could just go here and add, for example, a throw new exception instruction here. I can rerun this test, and now I should get a red with a 500. So yeah, here it is. So I've implemented a proper call to a controller in this way. So this is the concept that we are going to reuse for our accounts controller. Okay, cool. Let me just remove this exception, and okay, now we're good. Right. One thing I have in this other branch, and also you have, because I've shared the code on Discord, so go and check it out, is what I've done is adding this web test base class that contains all the logic for spinning up my web application factory. And for example, it already has a configure services method that will add the controllers of my bank API, so I don't have to do it each and every time. With this, I can just rewrite my values controller test that we just saw in this way. So I can inherit from a web test base. I can remove this piece of code and just do this build the web application factory, and the test stays. The rest of the test stays as it is, and it should just work. Yeah, test is passed. It's green. Cool. Okay, now we can start working on our accounts controller. So just as a reminder, because we've spent some time talking about technicalities, what do we want to do? So this is the scenario. We have an HTTP request, and this HTTP request is going through the authentication stack. Then in the request pipeline is going to hit the accounts controller. The accounts controller is going to send the request to the account service, run the authorization handler, and if everything is correct, will return me the response. Now, this pipeline involves a lot of moving parts, but actually what we want to focus on is just this bit here, if you think about it, right? So we don't need, for example, to involve the authentication and not even the real account service. So the idea behind this integration test is to mock or stub these added dependencies, so that the concept is that the integration test will, yes, be an integration test, but it will be as minimal as possible, right? So for example, we don't want to involve Azure Active Directory in our test. It would be just a mess, right? Dealing with tokens and things like that, right? So this is the idea. We're gonna use a dummy authentication, and we're gonna mock the account service, but we're gonna use the actual integration between accounts controller and the authorization handler to verify our logic. Okay, cool. So let's do it. So let me add a new class, which is going to be my account controller test. Right, and let me just use this. And what I'm going to do is basically, as you remember, the accounts controller has a few dependencies. One is the account service, and then there's the authorization service, right? And the HTTP context accessor. Now, these two are part of the ASP .NET Core stack, so I'm not caring about them. But this one is my code, so I actually want to create a mock for it, right? So I'm just mocking it and adding it as a singleton to my services. All right, this override configure services will basically just add these dependencies in my IOC container here of the web application factory. Now that I have this, I can start writing my tests. So for example, I can write a first test like this one: accounts when user is not authenticated returns a for 1. So the idea is that I build my application factory, I make a call to a given account, all right, and I expect a status code of unauthorized as a response. There's only one thing that we need to define. What does it mean that the user is not authenticated? Well, it means that none of the authentication providers, authentication schemes of ASP.NET have recognized that user, right? So what we can do is adding a dummy authentication provider through this method that I have created, right, which will configure an anonymous user. What this method does is registering a dummy authentication scheme handled by this handler. And trust me, the code will be more clear in a moment. In this version, will always return that the user is not authenticated, right? So this is our first test, right? Then we have a second test, which is something like this one. Accounts when a user is different returns a 403. And here I'm using the same extension, the same dummy authentication provider, but in this case, I'm configuring an authenticated user and I can pass a username for this one, which is, for example, Marco. And then I'm configuring the mock of my account service to return JSON as an owner, all right? Making the call, and I expect a forbidden. The way this code works is that, again, it will just register a few claims in the accounts principle. Go and have a look at the code. Pretty much the entire logic is in this dummy authentication options, which will return a proper authentication ticket to the authentication middleware, basically, based on the claims that I have passed. And you can pass whichever claims you want. Let's go to my last test, which is this one. Accounts when user is correct returns balance. Let me just run them in the meantime, and let's look at the code. So in my case, what I'm doing is saying, okay, when I'm just configuring an authenticated user, which is Marco. This time I'm making sure that the mock returns Marco as an owner, and the result is basically my account balance. And now, if we have a look at the results of my test run, effectively, this last one, when user is correct, is the one which is failing. So by running the entire ASP.NET pipeline, I was capable of reproducing the issue that I've seen when running the actual API here in PowerShell, right? And now that I have a test for this, I can prove that effectively there's something wrong. I can debug it, and I can also save you some time and just telling you that the reason why this wasn't working was that I forgot to add the authorization handler in the IOC container. So everything was working correctly, but I had forgotten to register this account authorization handler. So basically, my custom authorization code was never running. All right. Now that I fixed this issue, I can rerun my tests. Hopefully, they will all be green. Let's see. Yeah, all is green. And as you can see, it's 12 tests now, but it's still taking a very reasonable amount. Again, remember, I'm still running also the features, the BDD tests against a real database. So it's absolutely sustainable to have them run against the proper database. And everything is green. So now I can confidently go here, remake the call, and yeah, I'm getting the right results here. Okay, cool. All right, guys. So we have made another good progress here. The time is almost up. Before we leave, I just wanted to show you a couple of other things, which is basically, well, we can use this technique not only to test our controller, but also testing our dependencies. For example, I have a service here. Let me show you this. I have this loan controller in which I have an action called open new loan, which doesn't have a proper implementation. But at the moment, what it does is checking the credit score as a first thing. All right, it calls this loans service to check the credit score. And if you can't proceed, it will return a bad request. All right. And this check credit score internally, if we go and have a look at the implementation, is basically making an HTTP call to an external service. It's like a microservices architecture, right? In which my application service here makes a call to an external service to check if the user can actually open a loan. And how do we pass the user? In this case, what we're doing is that we are just passing the access token in this request on the new request, right? So basically, we are impersonating the current user of Bank API against this credit score web service. All right. Now, we can use a similar technique than the one that we've seen before, also to mock the behavior of this external service. All right. So in a test like this, for example, what we want to test is that we make a call to loan service, and this loan service will retrieve some data from the HTTP context. We retrieve a client from the HTTP client factory, and then we'll make a call to the external service. And we want to test that it's sending the right authentication header, and that it's dealing with the result of this service correctly. So if the result is that the test is passed, it's returning true. Otherwise, it's returning false. So even here, we're going to stub or mock all these dependencies, right? So we're going to use a pre-built HTTP context, a mocked factory to return my client for this external service, and we're going to use the web application factory to represent this external service here. And this is exactly what I've done here in my loan service test, right? So in my case, I'm building a web application factory, but for the credit check client, okay? So for my external service, and I'm exposing an endpoint which is a /check, and I'm storing the received header when this endpoint is executed, okay? Then I'm, you know, that since my iLoan service accepts an AI HTTP client factory, I need to create a mock for this to return the client for my fake service here. And then I'm creating a fake HTTP context, executing the loan service and verifying that the code, the received header is correct and the result in my case is true. As you can see, I'm returning true here each and every time. And I have some logic to create the HTTP context, which is not exactly trivial, but you can have a look at it. Another approach I can use is, I'm going a bit fast here because we're running out of time. Another approach we can use is using this this technique of a web application factory to run a full end-to-end test in which I receive an HTTP request. I go through the authentication loan controller, which will call loan service, and then the loan service in turn will call an external service. What I like about this approach, which seems a bit more complex, is that instead the code becomes a little bit simpler, because I can reuse all of the techniques that we've seen before, right? So this part is exactly the same. Credit check client is pretty much the same as before, right? I'm storing the receiving header, and that's it. But also I've created a second client for my bank API, running the build up, creating a web application factory for my bank API, and then all I make is a call to my API/loan, so to this guy, and then verify the results, right? So I also verify that the token received by this service is the same that I had originally passed here, right? It's a bearer and then token. I'm verifying that I got a successful status code because this guy is returning true, and yeah, that means that my test is passing. And I have a similar thing for my bad request from the sad path, right? The benefit of this thing is that, again, even though I have to spin up two applications, everything flows very, very natural. So I don't have to dig into the internals of the HTTP context, how it's built. I can just create I can just create a request running it against the first service and making sure that the second service is involved. Right, so the time is almost up. Let me just go back to these slides for 1 sec. Sorry. And yeah, just as a recap, what we've seen during this talk is we've run a bunch of functional tests with SpecFlow. We've understood how to plug the database in, and we've seen that we can do it also on Azure DevOps, or we can do it in GitHub Actions, or in any agent that supports local DB. We've added the web application factory to the menu, and we've understood how to use it to test the entire runtime pipeline and how to mock the things, concepts such as, for example, our authentication logic. You can also use it for authorization purposes, either with the authorized attribute or with the authorization service, like we've seen. And as a last thing, we've seen also how to use web application factory for either mock the dependencies if we are in a microservices architecture, and perhaps run a full service to service scenario. In the code which is in GitHub, you also see some other, I think, interesting scenarios where to use these techniques. For example, how to test hosted services in ASP .NET Core, like multi-threading, resource disposal, and things like that. So I think that's pretty much it. Let me just, as last thing, thank you for having been here up to 4 o'clock in a Saturday. This is my Twitter account or my email address. I'll be posting them on Discord if you want to get in touch. If you have questions, just feel free to hit me there. All right. Thank you very much.